limit as x approaches -4. Well, in this case, since the left-hand limit, okay, coming from the left equals what's called the right-hand limit, we're approaching -4 from the right, we would just simply say that that limit does equal 0. All right, so one more example here of doing a one-sided limit, and this one I'm not going to quite graph all the way. So we've got h of x equals the square root of x squared minus 25, and we're doing x is approaching 5 from the right. So again, we're looking at the limit as x approaches 5 from the right, the square root of x squared minus 25. Well, again, intuitively, I'm going to take numbers a little bit bigger than 5. So maybe, 5.1, 5.01, 5.001. So I'm getting closer and closer and closer to the number 5. I'm bringing it in closer and closer and closer. Okay, so again, we're approaching from the right. Well, if I take numbers a little bit bigger than 5 and square them, as they get closer and closer to 5, the number that I'm squaring is going to get closer and closer to 25. And if you subtract 25, well, it's going to get closer and closer to 0. So basically the moral of the story here is this function would be defined for numbers a little bit bigger than 5, and we can just plug it in. We would get 5 squared minus 25, which would be the square root of 25 minus 25, which would be the square root of 0, which is just 0. And that's all we've got to do is just plug it in. Notice you have to be a little careful. If somebody said, what's the limit as x approaches 5 from the left, here I would say this does not exist. It doesn't really make sense to ask this question. Because notice if you take numbers a little bit smaller than 5, well, if you square them, it's going to be a little bit smaller than 25, so that when I subtract 25 away, I would basically end up getting a negative number underneath my square root. And we don't take square roots of negative numbers. We're going to restrict ourselves to real numbers. And this would give us an imaginary number. So it wouldn't really make sense to plug in 5 from the left. Again, algebraically, if you plug it in, you just get 0, and you say, hey, it's 0. So these are things you have to, again, kind of be careful about. You have to really think, when can I just plug it in, and when can I not? So again, here, if I take something bigger than 5, it's going to be bigger than 25 after I square it. Well, if I subtract 25, I'm basically going to get something close to 0. It's going to be a little bit bigger than 0. But again, if you take the square root of that number, it's going to get arbitrarily close to 0. Okay, in this video, I'm going to do a couple just relatively basic limit problems involving absolute value. And it's just really kind of one thing that you have to remember with absolute value to kind of get started. So again, in the first one, I want to look at the limit as x approaches 1 of absolute value x minus 1 over x minus 1. Okay, so of course, again, the first thing you try to do with a limit problem is plug in the value. But notice if you plug in 1, we'll simply get 0 over 0. For those of you that have seen